Okay, hello students. Here I am walking through problems of lesson 8, practice problem. And the first problem. So sequence is, so you are being given f of 0. So this is the first thing. So the best way, as I always like to explain, is take a table. So the visuals are very clear what's going on. So what does this mean is in the beginning, that means very first, in this case, the first step, this zero step, this is called zero step. That means in the beginning, and then one, two, so it starts with this. The very first number is sequence in the first, the number in the first sequence is -20, and this is n, that's f of n. And then what does this mean? This is recursive definition. So again, I like to always repeat the same word. Recursive definition means always think of any term. That means if I want to know the number here, that means f of 1, and that f of 1 is always from the previous. So this is f of 0, right? So it is f of 0, and then this -5 that you see here, this -5, that's the d part or the rate of change. So what you'll do, all you do is you take away -5. So that means -20 and negative. So from here, -20 and -5. When you take away 5 from -20, so that's -25, right? So what is the meaning of explain? So the question is you have to put in your own English words. What does this, why it is like this? It's because in the recursive definition, what it does says is any term is 5 less than the previous one. And that's why you decrease it by 1 from here to here. Then the next one, what does f of 3 mean? So that means what is the f of 3? F of 3 is if there's a 3 minus. Why there are 3 minus? Because if I go from here to one more time, then you will take away, go down by 5, and that become -30. You go one more 5, and that become -35. That means you do it 3 times, 1, 2, and 3. So that's how you get. So basically, I want you to also write here. So the first one is f of 1. So the first one, f of 1 is, starts with -20, and it is -5 times 1. Look at this, can be written as f of 3 is, it's -20, and that means -5, how many times? 3 times. And that means if there is a 10 here, look at this, there is a f of 10. What does that mean? It is a -20, and that means every time you are decreasing by 5. So -5 times the same 10. So again, I use this pink color. So this means you are taking away 1 5. If this is 3, that means you are taking away 3 5. If it is 10, you're going to take away 5. Uh, Not this 5, 10 times. So this is how you get a formula. And you can also write the nth term. So what is the nth term? Is any number at any position is what you have in the beginning, and then you are taking away 5, how many times? N times. So that's what it means. But n starts with 0. Remember in the table that 0. So this means n starts with 0 and also 1, then 2, and so on. And instead of that, you just say n equals 0 and then greater than equal to 0. So it takes care of everything. So this is all you're supposed to write. So this is n term, or this is also called explicit formula. So what I'm learning from here is, one is recursive definition. What's the difference between recursive definition? See, the recursive definition here is f of, so you're given the first one is -20, and then after that you say, okay, at any place, it's always the previous one, means n minus 1, and you're taking away 5. But that's, and here you have to write equal to 1 and greater, because you're taking care of n equals 0 right here. So hope that really helps. So let's go to the second one. Yet another more practice. So another example is given, a sequence is given, doesn't say what, but by just looking at it, you know that sequence is starts with 0. So there you go. So 0, then 1, then 2, and then 3, and so on. And it's n and f of n. Now you're given the recursive definition. So any term at any position is always is the previous one, and either you add or subtract. But this time you're given minus 2. What does that mean is you're taking away minus 2. So you have a first number as start with negative 4 and then you go down minus 2. So that means minus 6. You go one more time minus, and each time you go down by minus 2. And that's all it is. So you're supposed to write what is the n term. So how do we find this? So you want to find this f of 2, f of 1. So for that you multiply, you you decrease by ones. But if I want to write f2, then you have to decrease twice. See? So from here you go 2 times. So that means f of 1, watch this, f of 1 is minus 4, and then you take away, see this minus 2, you take it this only once. Now I want to know 2, that means f of 2, in the beginning you had negative 4, but now you have 2, see, you're taking off 2 negative 2, so negative 2 times 2. Now I want to do 3, this is f of 3 is negative 10. So f of 3 is, it was negative 4, but now you have another negative 2 is taken off. I mean 2 is taken off, so it's minus 2 times 3. And likewise you can write the uh, nth term, and that is f of n equals negative 4. That's what you have. That's the main one. So then you go down by 2 and n times, and you're done. But then you have to also say equal to 0 and greater than equal to 0, and that takes care of everything. Let's go move to the another one. Question number 3, you are given a recursive definition. So there you go. This part is given. Okay, let's write that. That's the first one. So in this case, we begin with 1, 2, and then 3, and then 4, and then 5, and fn. So by just looking at this, see, look at this part. So this basically means you're multiplying. There's a growth factor which is multiplied each time. So the first number is 3, and then you multiply by 2. Okay. So first find the first 5 terms. So multiply by 2 times 3 is 6 times 2. If we multiply one more time, 12, one more time 2. So quite easy, right? And 248. So the next question is graph this. So we can easily graph this and see, because there is a multiplying to each time, there is a common ratio or the growth factor. So I write it a growth, and that's why this sequence is a geometric sequence. You can graph this also. So when it is 1, it is 3. So 1 is 3 somewhere here maybe. 2 is 6 maybe here. Not perfect. 3 is 12. 12 will be a little down here. 4 is 24. So 24 will be somewhere here. And 5 is 48. So likewise, you get the pattern. So this is geometric sequence, because from the recursive definition, the number at any position is always 2 times the number in the previous position. At the same time, we also need to write the nth term. So let's write that part also. Nth term or explicit formula. So how we write this explicit formula? The formula is, if I start with 1, now you should be going, if I start with 1, then the explicit formula f of n is always the first one. This means the first term plus the d, the rate of change. This is for the arithmetic sequence like this. But for the geometric sequence, it will be f of n, the very first one, and then you go on multiplying the ratio n minus 1 and equal to n greater than 1. So that's the difference between explicit formula for arithmetic sequence and explicit formula for geometric sequence. And why? And you can see, if I start with the 3 is the important one. This is what the 3 is. And then you want to go for 2. This is f of 2, right? F2 is 6. So how did you get F2 is 6? So F2 is because you had the pink color, you had the 3, which is the big one, and then you multiply 2 to it, right? So basically, I want you to focus on these two. So the step number is 2, the number in the second position, but here I can always write 2 minus 1. Okay, watch this one more time. What I'm trying to show is, let's see, f of 3. So what is f of 3? So this 12 is f of 3. So I don't have enough room. That's I'll write f of 3. The numbers in the third position is, and you can see how many times did you multiply 2. So you go once and you go twice. So in order to have the number from 3, you start from 3 and all the way you want to go 12. So you'll have to multiply 2 twice. So that means the beginning number was 3, the pink color, and then after that you're multiplying 2 twice. So you're multiplying twice. Basically, what it means is you have 3 and you are multiplying 2 raised to 2. But the same thing can be written as 2 3 times 2 raised to, because there is a 3 step number 3, I can write it this 2 as 3 minus 1. Look at the trend or the pattern that you see. The next one will be f of 4. It will be the same pink, and this time it will be the same factor 2 multiplied 1. If this is 4, it will be 1 less. That means it is going to be 4 minus 1. 3 minus 1. And likewise, if it is f of 5, it will be 3 times 2 raised to 5 minus 1. If it is 6, that will be the beginning number is 3 and is 2 raised to 6 minus 1. So finally, what you get is the n term. And say, okay, f of n is the beginning number 3, and then you multiply the growth factor 1 less. That's it. You're done. This is what important, but you have to also make sure you're writing n greater than equal to 1. Hope that is understood very clearly how, why, when to write this. Now, I just want to show, just imagine if if this graph had to start, if they, in place of this, they had to give us 0 onward, let's say, the same thing, everything same, but if they had to give us, if this was 0 here, let's say, okay, then that means you can start like this also, 1 to 3. Then the first one is 3, then 6. Of course, this number will stay the same. But how we write the nth formula here is the nth formula will change. So you start with, you say f of n, you begin the 3, and this time 2 is what you're multiplying each time. So it is 2. But don't write minus 1. It's going to be just 1 n, 2 raised to n, and it takes care of everything. Look, this time you have to say and he starts with 0. So you write 0 and then greater than. That's how the difference between this one and the one before I wrote was 3 raised to 2 raised to n minus 1. And there you say greater than. So this is the difference. So starting with 0 like this, then it's going to be n. But starting with 1 here, if this starts with 1, then this is how it works. Hope that helps. Thank you. Let's move on to the next one. Okay, now in this case, you are given the graph. All you're supposed to do is write the recursive definition, right? Now, the first number, this is 1, so that's 1, right? And that's 7 here. So 1 is 7. So if we make a table, 1 is 7. So starts with 1 is 7, and 2 is 5 here. So 2 is 5. So 2 is 5, 2 is 5, and 3 is 3, and this is 1, and 6 is minus 1. So it's 4, 5, 1, and minus. That's what you get. Now, the name of the sequence says is if it is n, it is m of n, right? So to find the recursive, It's always you start with the first one and you say m of 1 is 5. So the very first number. And then you say, okay, at the number at any position is always is the, is what you have in the beginning. That is 7. 7 what you have, or you can just say it. It goes down. So each time you reduce by -2. So that means there is a common difference, the rate of change. So all you do is it starts with the main number 5, sorry, 7. Of course, I'm sorry, I want to write recursive. So it's the one previous one. So the previous one will be m, but n minus 1. And then you decrease it by 2 minus 2. And this works for n greater than equal to 2 because you already taken care of 1 here. So this is called recursive. I'm going to write also the nth term. So I will write nth term. You can say mn is so the beginning is the starts with 7 and every time you take away 2 start with 7 minus and 2 minus 2 is the growth factor and then multiply by you put inside and my 1 left, so this one. Now why it is n minus 1? Because your sequence starts with 1, so this one, so that's why we write this way and say n greater than equal to 1. So this is the end. Or you can see the chart formula that I say mn is always m first one plus the d and then n minus 1. Now this doesn't mean you're substituting n minus. This means it's a d multiplied by the previous step. That's what it is. Okay, hope that takes care. Let's do the next one. Okay, now you can pause the video and see if you can do it by yourself because for the chapter test, similar questions are being asked. So first one, you are supposed to write the first five terms. So all each kg, it's better you make a table. So A1 is given. So here it is 5. So this is N and AN. That's for the first one. And we can, I think, do the same thing for all of them, like they say. So the N is common for 5, and then the rest we can say BN, and this is CN. Okay. And what does it say here is it starts with 5, but then you're adding 3 each time to the previous one. So this means the one before. So you add 3, so it becomes 8. Add 3 becomes 11. Add 3 becomes 14. So that's how you do it. Okay. And if I want to write nth term here, so it will be an equal the starts with 5, so 5, and then you are adding plus 3, right? And then you put n minus 1 and n greater than equal to 0, and this is the nth term. So two things are happening. One is if they gave you the sequence, and you can see it is a arithmetic sequence, and you can write the n term. You see the next one, multiplying by 3, so it's like so it starts with 1 here, and 1 times 3 is 3. 3 times 3 is 9, then 27, and then 81. So each time multiply by 3 here, and you want to write. You can easily write also the nth term and say, okay, Bn is the beginning. The first number is 1, so it starts with 1, and then you are multiplying 3. But remember, this step starts with 1, so you have to put n minus 1 and say n greater than equal to 1, and you are done. So that takes care. And the last one is looks like it is neither. Look at you any term is negative of the previous plus 1. That means it begins with 3. So you have to make it negative and then add 1, become -2. Again, you do the opposite, which is +2 plus 1 becomes 3. You do the opposite, negative plus 1 and negative. So, and you can see it alternates between 3, negative to 3, negative. So this is neither arithmetic sequence nor geometric sequence. sequence. And you can't write nth formula for this. You can write only the recursive formula. Okay, now again one more graph is given and then you're supposed to write. Is this arithmetic geometric? And by look at it only you know what is. So this starts with 1 and this is 1 is 64, this is 2 is 16, and this 3 is I think it is 4, and this is and so on, right? So you can clearly see it is a geometric sequence. Starts with 1. I'm not going to write everything. So it starts with 64, then becomes 16, then and something like this. So it goes down. So what is it? Well, no name of the sequence, and I can call this maybe G. I think I can call it as Gn. So these are the is this sequence arithmetic or geometric? So it is a geometric sequence because each time you take multiply 1/4 of the previous, right? So if you get confused, you always can divide, take a ratio 60 and divide by the previous one 64, which is 1/4. Okay, and that's how. Or you can do 4 divided by 16. So that's there is a growth factor. So R is 1/4. And we wrote this also. Recursive means what? Your first one, G of 1 is 64, and then after that, it's like just taking 1/4 of the previous, right? So that means any term, Gn means the number at any position is Gn minus 1 times R, and R here is 1/4. And this part is n greater than equal to 2. This is recursive definition. But if you want to write the n term, then it is Gn start with 64, and then how many times do you multiply 1/4? So you write that ratio 1/4 and raise to n minus 1 and say, hey, this is n greater than equal to 2. So each time I can see I'm trying to write every problem I'm writing recursive means what and geometric means. Remember the trick to write the geometric, the n formula. If it starts with 1, then you have to write here n minus 1. The exponent becomes n minus 1. So be careful there.